All right. So today, what we're gonna see mostly is designing how to design the environment, how to make it highly available, for resiliency and redundancy. That's very important for if you want to be an architect in AWS. That's one of the major concepts that you have to understand and you have to apply when creating an infrastructure in AWS. Okay, so what we're gonna cover in this module is it's how to choose a region, selecting the AZ or availability zone, the virtual private cloud, dividing the VPCs and subnets, the default VPCs and default subnets, controlling VPC traffic, connecting multiple VPCs, integrating on-premises components, and VPC best practices. Okay. Um, can you please mute the phones, please? Oh, okay, good. So
All right.
on Friday, okay, on Friday, you guys, I'm gonna log in the different way. The meetings, this meeting and the one that we did on Monday expire already. So we create a new meeting, and from Friday on, you will be required to register to enter the meeting. So register, I mean just put your name, your first name, last name, and your email, and then you can join the meeting. I need to capture the attendance, and that's the way that Zoom has for that. So you should receive an email today with a new link, so you can disregard the other links and just use the one that I'm going to see send today. Okay, I will let you know. So, what is the best practice? Improve the architecture. We're going to have an exercise in class, um, and then we're going to see how we can improve a specific architecture in AWS. Okay. So upon completion of this module, you will be able to discuss how to design secure, reliable, high-performing, and cost-efficient systems, highlight principles to consider when either migrating existing applications to AWS or designing new applications for the cloud. Also identify the design patterns, and architectural options that can be applied in a wide variety of use cases. All right, how to choose a region. So these are the four main things that you have to consider when choosing a region: the data sovereignty and compliance, proximity of users to data, availability of services and features, and cost effectiveness. Okay, so why is this important? For example, in the data sovereignty and compliance, your first consideration is understanding where you can legally host your infrastructure. What are the national and local data security laws? You have to keep in mind that your data will be subject to the laws of the country and locality where the data is stored. Now, is the customer data allowed outside of the country? Those are the questions that you should ask yourself. And the other question is, can you meet governance requirements? So compliance standards such as the United States Health Insurance Portability and Accountability Act, like HIPAA, have strict guidelines on how and where data can be stored. So AWS architects take all of these consideration into account when they evaluate where to host infrastructures. So did you know that AWS opened its first carbon neutral region in 2011? And now they offer 5 separate carbon neutral regions. That's an interesting fact that you should know about AWS. And but basically, when selecting a region, the first factor that you have to consider is the data sovereignty and compliance. You have to understand the local laws and standards before you do anything in the AWS architecture. That's the first point. Second point, what is the proximity to your user base? So latency is a very important point that you have to consider when architecting for AWS. You have to make sure that you are located very close to your users so that they can experience a good good latency. I mean, not good, low latency, and they can just get the data as soon as possible. Now, it says here that a study shows that 100 milliseconds delays can cost 1% in sales on Amazon.com. So can you imagine that? At 1% of sales in Amazon.com is a lot of sales, and just 100 milliseconds. And 100 milliseconds is fast, right? But see how important AWS considers latency. So customers expect responsive environments. And as time goes by and technology becomes more powerful, customers' expectations rise as well. Okay? They're expecting to see something state of the art and something fast, especially when they are dealing with a huge cloud provider like Amazon. So also, you have to consider the equidistant regions compare cost. For example, you have two regions that have the same distance from the user. You have to consider how much services are in a specific region and how much they are in another, because price vary from region to region. So they're not the same, okay? The fact that 1 gigabyte of data for S3 cost $1 in North Virginia doesn't mean that in Singapore it's gonna cost $1. So it may be more expensive in the United States than it is in Singapore. So that's very important. So you have to consider cost and latency as a second factor for architecting in the AWS infrastructure. So also the availability of services and features. Not all services are available in all regions. There are some regions that have one service and they are not in other regions. So you have to choose the region that possesses that service if you want to offer that service to your customers. So some services can be cross-region, but at increased latency. Okay, that's a point, also a very important point. And services expand to new regions regularly. So every now and then, AWS it's incrementing their services, expanding their services to other regions. But at the current time, if the service that you are trying to pursue is not in that particular region, then you have to choose another region if you still want that service, right? So
we don't see your PPT on the screen.
I'm sorry?
We do not see your PPT.
You don't see it? Oh, I'm sorry. Wow. One more, please. Wow. Sorry.
It's okay.
All right. You see it now?
Yeah, perfect.
Okay, thank you. Are you following me on your part?
Yes.
Yeah. That's what I'm doing.
Good. Okay, so we continue. Good. Cost effectiveness. Consider cost effectiveness. Service costs vary by region. I said that already. Very important. Some services, for example, Amazon S3, have costs for transferring data out. Don't forget that in AWS, you're charged by compute, storage, and outbound transfers. That's very important. And that's something that you see in the morning class as the basics. And consider replicating entire environment to another region. It's good to have replication in your architecture just in case one region goes down. It's completely, it's like blackout in your entire region. If you have cross-region replication, you're gonna be fine. So you can use a DNS service like Route 53 that has a failover routing policy, and once you have like a disaster in your region, it will automatically fail over to the other region, and then you're not going to have any problem with availability. So that's something that also solutions architects have to consider. Okay. So how many availability zones should you use? Do you have an idea, guys?
2, at least 2.
Is this Maria?
Yes.
So
you ask, you don't want to answer?
yeah, that's right. So how many availability zones should you use? Best practices is resources in one availability zone are reachable, your application shouldn't fail, right? So start with 2 availability zones per region. That's the best practice, right? Why? Because it's gonna fail if you have only 1. So most applications can support 2 availability zones. So don't be afraid of selecting 2 availability zones for your applications, because most of them can support that. So something to consider for heavy usage with Amazon DynamoDB. It may be beneficial to use more than 2 availability zones, just in case you want to be more redundant and more resilient. So you can use more than 2. It's just start with 2. You can have as many as you want. Of course, the more you have, the more you're going to pay, right? Because resiliency costs. It's not free. Okay. So using 2 availability zones. So here we have an infrastructure. We have a VPC, a virtual private cloud that has an internet gateway. Internet gateway is the service that allows your infrastructure here, right inside this VPC, to communicate with the outside world, with the internet. So that's the main objective of the internet gateway. It's just to open a door from the outside world to connect with your EC2 instances and your web servers. So in this case, like I said yesterday, we're trying to accomplish a single point of entry, like this guy here, this less than load balancer. So this guy is the one that's receiving all the traffic that's coming from the internet gateway. Okay, so the internet gateway has it accepts any IP address, right? So it's coming from the internet using port 80 or port 443, which is HTTPS. So HTTP is port 80 and HTTPS is port 443. So it's allowing traffic to come into our VPC through the internet gateway, and then the elastic load balancer is getting that particular traffic. And then these EC2 instances, they have security group, right? A security group is the one that is allowing traffic to come from this particular elastic load balancer. So this EC2 will not let anyone in, and in your EC2. Oh, I don't want to. Hello? All right. So again, so traffic is coming through this internet gateway, right? The internet gateway has, the incoming traffic is coming here. It comes to the single point of entry that has a security group that is allowing traffic from the internet gateway. Now the EC2 instances, they have a security group. Each one has a security group that is, remember, yesterday we said that security group is like a firewall, remember? A firewall is a security group that is allowing the traffic only from the elastic load balancer, okay? The single point of entry. There's no entry here or entry here unless it's coming through the elastic load balancer, right? So this guy here is in a public subnet, okay? A public subnet is a subnet that is not, of course, not private, so it allows traffic from outside. If it is private, there's no traffic into it, right? So if this one fails, you see this red cross here, big Rex cross, it means that this one failed. What's going to happen? The elastic load balancer will stop sending traffic here, because remember, it's going to be sending health checks all the time. Health checks. It's like a heartbeat. I want to feel your heartbeat every 60 seconds, every 300 seconds, whatever time you set up your intervals to send a health check. You know, if I don't get a response at a specific time, then I consider this EC2 instance unhealthy, right? And then I continue sending traffic to the other EC2 and don't send traffic here, because it makes no sense to send traffic to an EC2 instance that is not operational. So that's the way it is. Basically, two EC2 instances inside this VPC, right? And this VPC is inside a region, right? This is the region here. So region, the bigger guy. Then we have the VPC, small guy, the availability zones inside the VPCs. We have the web servers inside a public subnet that are inside the EC2, the availability zones. Remember, these two guys, VPC is the virtual private cloud. These guys, they work with subnets, right? They work with subnets. So you put the instance inside subnets. You put your resources inside the subnets for security, okay? To make this more secure and to segment your network, okay? You understand, guys? So this is a resilient, a highly available, infrastructure that has two availability zones, just in case one fails, the other one will.
Good question for you.
Go ahead.
Just go to the back. Okay. Here, where they put the firewall, the security measure between internet gateway and elastic load balancer here, or on both the instances between elastic load balancer and both the instances, where they put the firewall.
Can you repeat the first part of the question?
My question is that they put the firewall between internet gateway and elastic load balancer.
No, the firewall, the security group is right here. And the elastic load balancer has also security group that is pointing to this only.
Okay.
Security group, what they do, they open the door for traffic, right? So you can restrict traffic to a specific IP address or to a specific security group, right?
Right.
If you put a security group here that allows traffic only from this, no one can enter your your infrastructure through elastic load balancer unless it's coming from the internet gateway. Okay.
Right.
So that's the point. Restrict access to your infrastructure, use a security group, right?
Yeah. All ACLSs are there, access control list is there.
Yeah. But the control list, they operate in the subnet level.
Okay.
Right? In the subnet level. So you can have a security group here, and you can also have a NACL. A NACL is a network access control list here.
Okay.
It's like an extra layer of security.
Right. Thank you.
Recommended availability zones. How many availability zones should be recommended for each scenario? So applications that heavily use Amazon EC2 spot instances, we recommend, AWS recommends to use using 2 availability zones or more based on priced options. So that's a use case for that. Number 2, applications with Microsoft SQL Server, Oracle data sources, 2 availability zones to support active passive. And 2 or more availability zones for extremely high availability for applications with data sources using Cassandra, which is a database, or MongoDB. Okay, as you can see, in all of them, they have something in common. What is the minimum of AZs? 2, right? 2, that's the best practice, 2. And you start from there. You start from 2. Whatever needs you have, it depends on how much it's gonna cost, or the power that you need and the resiliency and the availability that you need, then you go from there. Take 2 or more, but minimum 2. That's something that has to be in your mind when architecting. Okay. So you may have in the test, you may have questions like, for example, 4 different scenarios where you have, you listen to me, guys, right? You listen to me.
Yes.
You there? Okay.
Yeah, yes.
Good, good, good. So you may have in the test a question like, for example, there's a company that wants to maintain minimum 6 availability zones. No, I'm sorry. They want to maintain minimum 6 servers, okay? Or let's say 10 servers, right? They want to maintain that minimum 10 servers. Now let me give you a question that says 3 availability zones, 2, 2, and 2. Okay, they may tell you, for example, an availability zone that has, for example, 5, 5, 2, or 5, 5, 5, for example, 5, 5, 5. They may have another one that says 2, 2, 2, or 3, 3, 3, or 4, 4, 4, or 6, 6, 6. Okay, now if you consider those scenarios, the only ones that match is 5, 5, 5 and 6, 6, 6. Why? Because in 5, 5, 5 you have 15 servers, right? You have to maintain 10 minimum. So if one availability zone fails, you still have 10, right? Because you have 5, 5, 5, right? 5, 5, 5. One fails, you have 2. So it's very unlikely that 2 will fail. 1 is likely, but 2 is very unlikely. So 1 fails, you still have 5 and 5. You have 10. So the other ones, for example, 2, 2, 2. If 1 fails, you have 4. That's not compliant with what we want. If you have 3, 3, 3, then if 1 fails, you still have 6. You need 10, right? So 5, 5, 5 works, but 6, 6, 6 works, right? Because if you miss 1, if one fails, you still have 12 servers. But which one is more expensive, 10 servers or 12 servers? When you have 5, 5, 5, 1 fails, you still have 10 servers, right? You have 6, 6, 6, 1 fails, you still have 12 servers, right? Which one is more cost efficient? 10 servers,
5,
right?
5.
5, 5, right? So there are 2 factors that you have to consider. One is cost and one is availability, right? And compliance with the company. The company needs minimum 10 all the time running. So what you have to do is create 3 availability zones, because I can create 4, right? I can create 4 availability zones and put 4, 4, 4, 4, right? If 1 fails, I have 12. But the more availability zones you have, the more costly it's going to be. So you have to consider cost and availability, right? So I think that 555 is the cheapest one, and it's the one that complies with what we need, right? So be careful in the exam. If they give you these scenarios, you have to be careful with that and understand that we're not only considering availability, but cost as well. Okay, you got it? Very important. You're gonna have those type of questions in the exam. And of course, when we practice for the exams, we're gonna have a lot of practice for the exam. Exams that you're gonna do on your own and exams that we're gonna do in class together as a group. You will see scenarios like that one. So you will be able to understand and just get all the tricks and all the strategies for the exam, because AWS is very I don't want to use the word mean when it comes to exams, but it likes to play tricks on people. They give you a lot of confusing questions, and then you have to be ready for those. Okay. Okay, virtual private cloud. Okay, so there are 3 limited use cases where one VPC could be appropriate. Okay, so you can have one VPC or multiple VPCs. For example, high performance computer environments. So that could be appropriate for that one. So you may have an environment that's computing is high performant, and you have many resources. You don't need to decouple your infrastructure like we spoke on Monday. Decoupling, several components, small components, to then form the whole thing. When you have limited resources and all that, not limited, few resources that you're using, a high performance, like high performance computer environments, it's appropriate to use one VPC. So for example, when you have Microsoft Active Directory, which is another service that AWS has for connecting the Active Directory in your on-premises and AWS, and then you can sign in into AWS and I have access to your resources using your password and your username from your premises and all that. You can have a one VPC, right? Or you have a small single application managed by one person or a very small team, you can have a VPC. Now, you can have a VPC for your HR department. You can have a VPC for your accounting department. You can have a VPC for your developers, for your administrator. You can have different VPCs for different departments in your company. But what it does is it isolates one from the other, okay? And they can have connection, the two of them can have connection using something called VPC peering, okay? VPC peering. So you can connect using private links, all that, connect the two VPCs, or the VPCs. Now, it is not, you cannot, if you have VPC A, VPC B, and VPC C, if you connect VPC A with VPC B and VPC B with VPC C, there's no connection between VPC A and VPC C. This is not transitive. There's no transition here. You have to connect one by one. You have to connect A to B, B to C, and A to C. The fact that B is connected to A and B is connected to C, it doesn't mean that A is connected to C. So AWS doesn't support that. So you have to connect one by one, okay? So that's the way that VPCs can be connected. Now for small use cases, for most use cases, there are two primary patterns for organizing your infrastructure, multi-VPC or multi-account. When we get to organizations, we can understand how you work with multi-accounts, okay? But multi-VPC is a very good move, smart move, because you can have an isolated environment for every single department in your company, as well with multi-accounts. So those are the two primary patterns for organizing your infrastructure, okay? So we saw high availability, and now we're talking about the networking component and how to have different scenarios, when to use multi-VPCs or a single VPC. Okay, so we have here the two patterns, multi-VPC and multi-account patterns. So we have here several VPCs, one for shared services, one for development, one for testing, one for production. So it's very important to connect those using what I said before, right? What I said before, peering, VPC peering, right? To be able to, for example, for development, to be able to connect and get resources from testing, or pass some code that is already ready for testing after it is written. You write the code and then you just pass it to testing. But all of this, what is behind the scene is a thought behind the scene. There's a thought of security, okay, and they are isolated, okay. So one doesn't depend on the other, even though that you can connect them, they don't depend on each other, okay. So you can cement your infrastructure using VPCs. That's a very good best practice for that. Also, multi-account, you can have an account for shared services, development, test, production. Doesn't mean that you have to use both. I don't think it makes sense to use both, because what's the point of having an account that's shared services and a VPC that has the same name, okay? So you can use either one, whatever is more suitable for your company, you can use it. But these are the best patterns that you can use for most cases in AWS, especially for businesses that are big, large scale, and companies that have multiple departments, okay, or multiple teams. Very important. So the multi-VPC pattern is best suited for single team organizations. You can use it for single team too. You can use it one, or you can use it different, organizations such as managed service providers, limited team make maintaining standards and managing access for far easier. You know, the more teams you have, the more complexity. You know, if you have less teams, it's less complexity. It's easier to work that way. Okay. Now there's an exception. Governance and compliance standards may require workload isolation regardless of organized complexity. So maybe there's some companies that need to be compliant with a specific higher rank organization, and it doesn't matter if they have a lot of complexity, they'll still need to have isolation from those workloads. So we have multiple VPCs on multiple accounts. Yeah, there's some companies that every now and then they audit it. They get some auditors, and then they have to be compliant. And it's good to be well separated, you know, in micro accounts. That's much better to be organized and to be more, you know, more resilient, if you can say it that way. Okay. So the multi-account pattern is best suited for larger organizations. Let's say that you know, you have tons of departments. For example, when I worked at the college board, there were tons of departments. It was like a large building of 20 floors, and crazy. Every time you were on a floor, you should probably 10, 12, 15 departments on every floor. That was absolutely crazy. Even you know, college board. The college board is the company that created the SAT, so they have millions and millions of customers, and they have to be very well organized. So they use multi-account pattern. They use that because I was there and I saw it. They have accounts for developers. They have accounts for testers. They have accounts for no HR, all the department that you can see in a company, and they were very organized. They still are, and they have service level policies, and also they have users with limitations and groups and roles and all that, and it's very organized, very organized. So AWS organizations, that's something that is going to be in your exam, and it's something that you have to understand, right? So you can find that in your console. If you go to AWS policies, and also they have okay. So if you go to the here, one moment. If you go to Amazon, and you log in here, I can type here AWS organizations. Web organizations only, I think it's enough. So I can just put organizations here. Okay. And then you can put here this organizations, and you can create an account here. But the point of this is that you can organize your infrastructure with organizations. You can organize accounts. You can have a root here, and under that root, you can create different policies, and you can create organizational units, because the way an organization is structured is by organizational units, or OUs. That's the way it is. Okay. Now that's something that we can see later if you want to. So, one moment, guys. So we have here account management service, consolidate multiple AWS accounts into organization and arrange AWS accounts into organizational units, consolidated billing and account management capabilities. Okay, consolidated billing is very important because you can have like 5, 6, 7 accounts in your organization, and then you can have only one bill. Only one bill. By the way, this is free. This is free. You can have only one bill for every single account. That includes all the costs of the single account, and the bill is going to be given to the root account. That's the one that has that bill, and it's going to include all the costs that are incurred by every single account. All right. So what are the features of these organizations? You have hierarchical grouping of your account. Is going to be in the tree-like structure. Integration and support for AWS identity and access management, so you can control authentication access there. Integration with other Amazon Web Services, data replication with eventual consistency. Eventual consistency is what it means is that when you update your information in the core, in the main section, is going to be replicated asynchronously. What it means is that it's not going to be available right immediately after you make the change. So it's going to be eventual. You know, that what it means is that if you try to see the change immediately, it's not going to happen. It would take some time for the data to be updated. So that's what eventual consistency means. Okay, and caching may improve performance. Of course, when you have caching, your application is going to be faster in every aspect. Okay, so this is the way it is structured. So organizational units are structured starting with the root guy. That's the account that we created, right? And then we create organizational units, right here. Okay, and organizational units, inside that one we can create another organizational unit, right? Like this one here. And then an account is going to be here. So you can create accounts inside the organizational unit, right? Now, let's see an organizational unit as a folder, right? It's a folder. It's like a folder system where you have the root account, the root folder, and then inside that root folder, you create all the folders, right? That's organizational unit. Now, inside that, you create the accounts, right? Let's say that your business has multiple accounts, so you can create those accounts inside organizational units to make the accounts more structured and more organized. Now, here you see next to root, you see something called policy. What is policy? A policy is a document. It's a document that is written in JSON. JSON is JavaScript object notation, right? I think I spoke about that on Monday. It's a key value pair object notation, where you have a key and a value, and you can find the value by the key. Now, if you apply a policy to this particular organizational unit, everything that is under that OU is going to be affected by that policy. Okay, let's say that here in this organization policy, I only allowed people from the development department to access this part here. Okay, so only the development department can access this organizational unit. So I create a policy that says that only the department that has the developers or the group can only access this. Now, every single account inside this are going to be affected by that. Only developers can access this. Okay, now, if the policy goes straight to the account like this one, guys, I'm going to ask you a question. Do you see my cursor?
Yes.
Okay.
Yes.
So, good. So we have the policy here. The policy is applied to this organizational unit. It means that only this account will be affected by that policy. So it's just the level of hierarchy. If you work on the level here of the folder, everything inside this folder will be affected by that policy. If you go to the level of the account, only that particular account will be affected by that policy, right?
It's like GPO in Active Directory.
Yes, similar.
Okay.
Yes. Yes. So here, this policy affects this folder. It means that everything inside, even this account, will be affected by both policies, this one and this one. Okay? Because this policy is affecting this folder. So it's going to influence on this one too, right? This account is going to have two policies. Now, this one is going to affect this particular folder, but not this one. Okay? It's going to affect this folder here. That's why this account is not going to be affected by this one. Do you understand this, you know, spaghetti ball?
Yeah.
Okay. So this folder is going to be affected by this policy. Therefore, this account is going to be affected by this policy because this account is inside this folder, this OU. Okay. Now, this policy affects only this OU, right? Only this OU that affects these three accounts. I think it's self-explanatory. It's not difficult to understand. It's just, you know, look at the structure here and the policy that you can apply to different organizational units.
I have a question.
Go ahead.
So I'm going to equate AWS account to an account to a person, right? Is that correct?
Account is not for people, it's for departments.
An AWS account.
Yeah, usually in your case, you have one now because it's only one person, right? But when you work for a business, the account is not yours. You're going to be working in an account, but the account is not yours. So inside your account, there's going to be a whole department.
So AWS accounts are not IAM accounts. Is that correct?
No, an IAM is access, identity and access management. That's something that you can apply.
At the user level.
That is correct. At the account level, what you have is a service level policy.
Ah, okay. So I was thinking that the AWS account is an IAM account.
No.
So it belongs to a user, but you're talking about.
Yeah.
Okay.
You can create users, groups, and roles with IAM, but you cannot create an account because the IAM access identity and access management, it's already inside the account, and then you can use that to restrict access inside the account. Okay, but this kind of policies is what we call service control policies. That's what you apply to the account, right? Access management is at the user level, right? At the user level, group level, and role level. Service control policies is at the account level.
Thank you.
You're welcome. So we have this here, okay? So you never apply an IAM policy to an account. You apply a service control policy, right? Also known as SCP, okay? SCP, very important. Okay? Now, what does AWS recommend? Never use your root account. Never use your root account. It's not recommended. Why? Because the root account is the one that has all the privileges. If I get access to your root account, I got access to your entire infrastructure. Okay? So what AWS recommends is to disable the keys that are in your root account. Disable the keys, because if someone gets a hold of those keys, they would get access to all of this inside your root account. Okay, that's best practices from AWS. Never use your root account for production. You can use it for your practice for this exam, right? But for production, never use the root account. Always create users. We're gonna see how to create users in AWS, and with users, you give them access either to the console or programmatically, like the CLI, like the SDKs, the software developer kits. but do not use the root account. Very important. Okay. Other important considerations. The majority of AWS services do not actually sit within a VPC. Okay, so putting everything in a VPC, it's optional, right? It doesn't have to be in a VPC, but it's just you know, it's very important to put in a VPC for more control, more security. So the network traffic between AWS regions traverse the AWS global network backbone by default. Everything goes by the backbone network of AWS, right? Everything that happens in AWS. Sometimes the traffic between regions uses the public internet, right? So not always the traffic is between VPC and VPC. That's what you have to understand, right? In the case when you create a EC2 instances, you have to put the EC2 instance inside VPC. So we saw it this morning, probably in the afternoon when we have some time, we can do the same. When you create an EC2, you have to put it inside a VPC. That's for sure. That's a fact, right? Now, not all the traffic happens inside AWS, okay? You may also have public traffic coming from the outside world, from the internet, okay? That's something not difficult to understand. It's very simple. For example, Amazon S3, DynamoDB offer VPC endpoints. So the VPC endpoints are mostly to access resources inside your VPC, inside your AWS infrastructure, because you can access resources from another account in another region, right? But if you establish VPC endpoints that are powered by private links, you can connect without using the internet, okay? Without traversing the public internet. So you can stay inside the AWS network and not use the internet. And for that, you create VPC endpoints. That's very important too. Okay. Okay. All right. So what is the main objective of creating all of this VPC thing? It's security and more organization, for sure. So when you create a virtual private cloud, you have to specify its set of IP addresses with classes, and this is called CIDR. I don't know if it's CIDR you know, have you ever heard about CIDR? CIDR is classless interdomain routing, okay? You have to specify a router. It's like a range of all the IP addresses that you're gonna be able to create inside your VPC, okay? So there's an example of an IP address that has a notation of 16. So this IP address, what it does, it gives us all the available IP displays in the range from 10.0.0.0 to 10.0.0.255. Now, how many hosts can we have here? Well, we have 16 here. We can have up to 65,565 hosts available, okay, when we have this. So when I mean host, what I mean is computers, servers. That's so you can allocate IP addresses for that amount of servers, okay? So how does it work? So every 3 digits here in an IP address represents a set of 8 binary values. So 8 bits, right? So we have 8 bits here. 1, 2, 3, 4, 1, 2, 3, 4. So we have 8 bits. Remember, a machine doesn't understand letters. It doesn't understand letters. It understands zeros and ones, right? Zeros and ones. And every single letter has a notation like this is binary notation, okay? Every single letter. If you look for, I think it's called Ascii. Have you heard about Ascii? Ascii codes?
Yes.
Okay, ASCII codes, every single letter in your computer, when you look at your keyboard, A, B, C, D, the comma, semicolon, every single letter has an ASCII code because the computer doesn't understand A or B or C or comma or colon. It understands zeros and ones, right? So the ASCII code is a number, and that number can be written in binary code, right? So I recommend watching how to, there's a video that you can watch because we don't have time to explain this here. There's a video that you can watch how to change from decimals to binary or from binary to decimals. You can see that in the video. But what you have to understand is that an IP address has 32 bits, 8, 8, 8, 8. So every number here represents a set of 8 bits. So number 10 is 0, 0, 0, 0, 1, 0, 1, 0. How do you know that? When you watch the video that I'm gonna send you after class, you will understand where this number here is coming from, why it is 10, right? And of course, 0, 0, 0 is gonna be 0. Everything is gonna be 0 because it's 0. There's nothing here. Everything is off. So this one is on, and whenever you see a 0, that means that bit is off. When you see a 1, it means that bit is on. So more explanation of this, the video you're gonna watch when the class is over. So if we were in a classroom where we have more time, or if this class was a class that has for more than 3 hours, I'll be more willing to explain IP addresses and all that because that alone is an entire class for networking. So in this case, we have another IP address. Remember, when you have a 16 notation, what it means is you can have all the addresses between this range, which is this IP address and this IP address, right? So we have number 10 here. Number 10 is represented by this binary thing. It's 8 bits, the same as here. And you have 0. And then 255, it means that all the bits are on. 1, 1, 1, 1, 1, 1, 1. All of them. Okay? So we have this one is on too. All right. So the takeaway of this is that IP addresses, they are formed by a 32-bit thing, 32 bits, but every section represents 8 bits, right? Is binary. 8 bits, 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 8 bits. 32, this IP address, 32. What is an IP address? It's a location of a device in the network, okay? That's an IP address, a location of a device in the network, okay? And we're gonna have devices, right? In our infrastructure, we're gonna have EC2 instances. That's a virtual device, it's a virtual server. And that server is gonna have an IP address, right? A public and a private IP address. The public IP address is the one that the outsiders are gonna use to connect to that EC2 instances, either an elastic load balancer or whatever is before that EC2 as an entry point. Okay, that's mostly it. Now, this is thing in the CIDR notation example represents how many of those bits are locked down and cannot change. So these guys are locked, okay? They cannot change because one represents the host and the other one represents the network, okay? But these two can be changed. And all the hosts that we're gonna be accepted are here, okay? So when we have 16 here in the CIDR notation, it means that these 16 bits here can accommodate 65,535 servers, IP addresses. That's what it means. Pretty huge, yeah? So with this, we have a combination of over 65,000 hosts that we can put here. Okay, that's what it basically means. So the unlocked bits can change between 1 and 0, allowing the full range of possible values. So like I said before, you can accommodate 65,000. So the lowest is all zeros. The lowest we can go is all zeros, and the highest we can go is all ones. Okay, that's the lowest we could go, and the highest. So all the IP addresses are going to be in this range. All right. So probably here 1.0, 2.0, 3.0, 1.2, 1, you know, like subnetting here, everything. Okay. For example, you see here. So we have a CIDR notation of 16. We have here bits available, like total IPs is 65,536. You see, the higher the number, the smaller the total IPs that you can allocate. Okay, so we have here, this increments by 1, okay, all the way to 32. It increments by 1, right? All the way to 32. Of course, you can have 15, 14, 8, you know, all the way to 32, 1 by 1. But here, if you notice, they are decreased by the half. If you multiply this by 2, you're going to get this. If you multiply this by 2, you're going to get this. If you multiply this by 2, you're going to get this, and so forth. So the number here in the CIDR notation increments by 1, and the total IP addresses that you can allocate are decremented by 2, by the half of that. Okay? So if we have a CIDR notation of 19, we can only allocate 8,192 IPs in total. Okay, in AWS, the higher you can go is 16. Why do I say the higher? Because even though the number is 16 and this one is 28, I'm sorry, is the one that allocates the highest number of IPs, right? So the highest you can go is 16 and the lowest you can go is 28. Okay, so bear that in mind when architecting in AWS. The highest you can go is 16 and the lowest you can go is 28. Okay, those are the CIDR ranges in AWS. Okay, any questions?
No, right now.
Okay. So what are subnets? Subnets is a way to segment your network, okay, to make it more organized, more segmented, more decoupled, right? Now, there are segments or partitions of a network. You divide the network in subnets. So every subnet is going to have a CIDR range as well, right? So let's say that you have a VPC with CIDR 22. If we go back, CIDR 22, just CIDR 21 is going to be the half of this, and CIDR 22 is going to be the half of this, right? Now with the CIDR 22, we can have a total of 1,024 total IPs, right? Now, then you can have 4 subnets: subnet 1, subnet 2, subnet 4, subnet 3, subnet 4. Okay, so each subnet is gonna have 256, 256, 256, 256, 256. It is a total of 1,024. Now, what happens when you create a subnet? Automatically, AWS will take 5 IPs that are reserved from every single subnet. That's why you see 251, 251, 251, 251. That is something that AWS does, right? Now, the network address and the broadcast address, if you know a little of networking, you understand this. Otherwise, I recommend taking a look at a video that explains CIDR. But this is what you need to know for this exam, is that the first one and the fifth one, that's a standard for every single network component of every single infrastructure, and not only AWS. Number 1 and number 5, it is standard in networking, standard. Okay, because you need to have a network address and a network broadcast address. You need to have that. Now, AWS will take the second one, which is .0, 10.0.0.1. It would take for the VPC router, because the VPC has a router, right? All networks have routers because they are the ones that connect networks, right? So AWS would take the one, AWS would take the second one to the third one, which is reserved for AWS for mapping to Amazon provided DNS. That's the Route 53 service. And the other one is reserved for future use, just in case you want to use it in AWS. So five. So whenever you create a subnet, you have to consider, before you ever create it, you have to consider the 5 addresses, 5 IP addresses will be taken by AWS. So if you're planning to have an infrastructure that needs more than 251, then you have to create a bigger CIDR. You cannot create this one that has 22. You have to create one that is 20 or 19 or 18. You have to create that, because once you create your VPC, you cannot change the CIDR. So before you create the CIDR, before you create your network, you have to think that probably in the future, you may need more IP addresses than 1024. You may need more. So you have to plan ahead before you create your VPC and create plenty of IP addresses. So you have to go for a higher CIDR, because once you create it, like I said before, you cannot change it. Okay, that's very important.
I have a question. Which one usually you recommend to take, like CIDR, 22, 24? Which API range?
It depends on the size of your company. It depends on the traffic. It depends on your resources. Usually people, big companies start with 16, to allow for a lot of IP addresses, but you don't want to waste IP addresses, right? So you have to be clear. Sorry?
The small company usually.
You have to see how many resources you're going to use. You have to, I think it varies from company to company. You have to see how many servers you're going to have in place, how many IP addresses you're going to need. It's something very subjective that goes with the company size and the company capacity, right? But you have to know your infrastructure even before you start planning all this, because you have to allow for plenty of IP addresses, okay? Because like I said before, if you need more and you don't have that capacity, you cannot change the CIDR. You will have to create another VPC, okay? So once the CIDR is in place, you cannot edit it. You cannot change it. So plan ahead, talk to your networking guys in the company. There should be a network department, an IT department. Talk to them, or if you are expanding your business, talk to your IT guys and see how many IP addresses you may need in the future. You don't want to waste IP addresses. You don't want to create a CIDR that's going to have tons of IP addresses that you're not going to use. That's bad practice, because you're wasting IP addresses. So you don't want to be under provision and you don't want to be over provision. So you have to be somewhere there close to what you need. Does that answer your question?
Yes, thank you.
So private and private subnets, public and private subnets. So when do we use public subnets? When we have resources that can be accessed from the internet. Okay. Bad practice: never put your database in a public subnet. Never do that. Your database should also be in your private subnet. Nothing that is important should be in a public subnet, because a public, like the word says, public, it will be accessed from the internet, right? So good practice, important, confidential data should be in a private subnet, right? So if the subnet's traffic is routed to an internet gateway, then the subnet is public, okay? So if someone asks you, asked you in an interview, what's the difference between a public and a private subnet? Very simple. Public subnet, they have a route, because every single subnet has a routing table, right? So a public subnet has a route table that goes to what? To the internet gateway. Okay, and remember, the internet gateway is the one that connects your subnet with the outside world, the internet, right? That makes a subnet public, you know, routed to the internet gateway. If it is now routed to the internet gateway, you know, it's private, right? So that's the simple answer of that. You may have that in an interview, because I've seen those questions, and I have myself those questions in an interview. All right, very important. So what is the recommendation? Use subnets to define internet accessibility. Okay, it's very good practice to use subnets for internet accessibility. So include a routing table entry to an internet gateway to support inbound and outbound traffic access to your public internet, right? Okay. Like I said before, every subnet has a routing table, and routing table by default already have a route that says local route. It means what it means is that those resources inside that subnet or that VPC, they can connect with each other. That's the local one. So you can create custom routes, right? Custom routes are the ones that you can connect to the internet through the gateway. Just the internet gateway will have a particular ID. The internet gateway ID is going to have that starts with an I, internet gateway. And then when you create the route, you can say, I want traffic coming from this particular ID, which is the ID of the internet gateway. And that's the way you connect your public subnet to the internet through the internet gateway, okay? By just putting a custom route, adding a route to your route table, but because by default, it doesn't allow traffic to the internet. But by putting a custom route and pointing that to your internet gateway, then you can access the internet easily, all right? So in a private subnet, do not have a routing table entry to an internet gateway and are not directly accessible from the public internet. Of course, the private subnet has a local one, has a local entry, routing table entry. And also you can have a custom one that connects your private with your NAT instance or NAT gateway. I don't know if you guys received some documentation about difference between a NAT gateway and a NAT instance. I think I scheduled it for yesterday. Did you get it?
Yes, I got it.
Okay, so a NAT gateway or NAT instance is the device that is put in a public subnet for those instances in a private subnet to connect to the internet through that NAT gateway or NAT instance. Now, why would I need to connect to the internet if I from a private subnet? Very simple, because you may need to update your database. You may need to patch your database. You may need to download some software of something from the internet. So you will have to connect to the internet, but it's gonna be directly to the internet. It's gonna be through a NAT instance, which is basically an EC2 instance, but it's a NAT. And it's a special kind of EC2 instance that you don't create, right? You can get it from the AWS marketplace, right? You can get it from there. You can just type in NAT, and it will show you the NAT instances that are available. You choose one, and that's it. It's gonna have some security group and everything like any two EC2 instances, And what you have to do is in your private subnet, you can create a local another entry that points to that NAT instance, and that instance is going to have a security group that points to the internet gateway, right? And then that way, through the NAT instance, which is like I would say like another layer of security for your private subnets, you can access the internet and download things that you need. So this NAT is also called jump box, like you see in your PowerPoints, jump box. It's also called NAT, and Network Address Translation. That's what it stands for. A proxy, a proxy server is a server that. Have you ever heard or seen? Sometimes when you send, you are in your local network, like the internet of your company or something, that there's like a filter that doesn't let you send some emails with specific words that they don't want. For example, I come from Cuba. I've been in this country for 13 years, and I worked for a medical school. And there's a lot of Cuba is a country with tons of restrictions. Everything is a restriction. And in that company, if you wrote an email that mentioned Fidel Castro, the ex-president of Cuba, or any bad words, or any word that was against any any ideology of the Cuban communist system, the email will never go out. It will be intercepted in the middle, in between. What is that? That's a proxy server. A proxy server is the one that is in the middle. It's like an interceptor of traffic of any particular words. It has filters. So that's another way to offer security to your subnets, by having a proxy server that every single incoming request has to come through that proxy server. No other single point of entry. That's the only one. A Bastion host is the same thing. It's similar, almost the same. It's just has a different name. It's a EC2 instance that is called a Bastion host. But basically, a takeaway of this is that there's always one guy in the middle, either a NAT instance or a proxy or a Bastion host or a NAT gateway, that will not allow traffic to the private subnets at will. It's something that you set up in your infrastructure, but no traffic will come to the private subnet because the private subnet is not connected to the internet through an internet gateway. Okay. So it supports restricted outbound only public traffic access. So only outbound, no inbound traffic, okay? Nobody can access the private subnets. Private subnets can access the internet through these guys that we just talked about, okay? Very important. Confidential data, important data, sensible data, everything that is not to be exposed to the public should be in a private subnet, okay? How to use subnets. We saw already, okay? Good, sorry. Subnets recommendations, start with one public and one private. That's what AWS recommends, right? Per availability zone. So we have here 2 availability zones, A and B. So we have a couple of subnets for each one. So here we have this guy here with 24, 24, the CIDR notation, 24, if we go back. So we have 24 here, it should be 256, I guess, 256 host. So we're gonna allow 256 here, 256 here, and 23, we're gonna allow 160, 256, 128, right? 128, 128. Remember, the higher you go, I'm sorry, not 256, the higher you go, the
The more IPs.
the smaller it's going to be, right? The higher you go here. 24 has more IP addresses than 25 and more than 26, right? If you go down, you're going to have more IP addresses. So 24, it's, I think it is, let me see.
256.
256, right? It's right. It's what I said. 256. Very good. Thank you. And then 223 would be 1022, 124. No, 512. Sorry. So here we have 512. Do we actually have 512?
No.
What do we have?
-5.
57, right? 507, right? Don't forget that. Always take 0.1, that 0. And here 10.0.2 and 10.0.4. What does it mean? It means that the CIDR cannot overlap. It cannot overlap. I cannot put 10.0.0.0/24 here in this subnet. I can't, right? It cannot overlap. I have to play with this bit here and change it. 2, 4, 1, 5, 6, 7, right? They cannot overlap. Of course, if we have another VPC, yes, but inside this VPC, it cannot overlap. Okay, very important. I can have another availability zone here, availability zone C, and then I can have 2 more subnets, one public and one private, and then it's gonna be 10.0.5.0, and then 10.0.6.0. It cannot be the same. Okay, very important to understand. And recommendation.
Okay.
Go ahead.
Question. I have a question.
Yes.
So if availability zone A is completely separate from availability zone B, why the public subnets cannot be mirrored to each other if we're talking about replication?
Because it's not per availability zone. It's per VPC. Even though they're different.
So what's the oh, okay. So at the bottom of the window of the slide, it says availability zone A and B, right?
Yeah, but they're both inside this VPC. Right?
Ah, okay. So we always go back to the higher level.
That's right. So you have the CIDR here, that 2021. 21 it has 22 has 10 24. 21 is going to have 2048. Okay, 2048 hosts, and you're going to have all these guys here. Now, the overlapping happens per VPC. Okay, so if you have another VPC, you can have the same thing. Again, same thing, but it's not per availability zone. It's per VPC, because these availability zones happen to be inside the same VPC. Okay, so you can have 10,000 VPC of availability zones here. Well, not 10,000 because you don't have that amount in AWS, but you can have 5 availability zones here. You're gonna pay more. Don't forget that. Okay, because you have more resiliency and more high availability. But you will have to change tweak this IP addresses, these CIDRs, because they cannot overlap as long as they are inside the same VPC. Okay, understood? Okay, so recommendation, locate substantially more IP addresses for private subnets than for public subnets. Why? Because the majority of resources on AWS can be hosted in private subnets, the majority of them, right? What do we host on public subnets? Web servers, right? Things that people can access from the internet. But most of the data, the most important things, the majority of things of an application will be in a private subnet, because we don't want anyone to know about our, inner things, right? So what you have to do is use public subnets, control access to and from the internet unnecessary. That's for the public subnets. But you have to allocate more IP addresses for private subnets. Don't forget that, because you're going to use more resources in your private subnets than in your public subnets. Okay, so all of everything that we've seen so far, they all point to a highly available infrastructure. Okay, and I think it's time for a break, guys. So take a 10 minutes break, and I will see you again in 10 minutes. I'll see you at 2:35.
Thank you.
You're welcome. So guys, it's 2:35. So we're back here. We continue with this topic of subnets and VPCs and subnetting. Okay, so recommendation by AWS, they consider having a larger subnet over a smaller one. When it says 24, larger is 24 and larger, what it means is that you can have 24 or larger. It's 24, 23, 22, 21, 20, 19, and so forth. That's what it means by larger, okay? Why? Because it's simpler to choose where to place and where load in a large subnet than in 10 small subnets. That's more complicated, okay? You're gonna have more work to do if you have 10 small subnets than if you have a big large. Let's say that having 116 is much better than having 10 24, okay? So it's better to have 116. Well, I'm just putting 116 as an example. It all depends on the business needs. It could maybe the business needs 17, 19, depending on how many IP addresses they need. But it's better to have a large one than a few small ones. That's the recommendation by AWS. So it's less likely to waste or run out of IP addresses. If your subnet runs out of available IP addresses, you can add more to the subnet. Okay, so that's what I said before. You cannot edit your subnet. You can't. Okay, so you have to plan ahead before you go ahead and build your network component. Okay. Select the subnet types. There's different types, public or private. Okay. So for databases, like I said before, use private, right? Everything that has to do with connections and confidential information, all that, use the private subnet. For batch processing instances, instances that process jobs in bulk, a lot of jobs, all that, use private subnets. For backend instances, all the databases, all the applications and everything that are in the backend where the user cannot see, that's the backend. The front end is what the user sees in front of him or her. The backend, that section of your application where you put the most important information, that should be in the private subnet. And then the web application instances, that can be either public or private. It's just a matter of opinion and option. It's optional. Okay. So that's that. Now the default VPCs and default subnets. By default, when you create an account with AWS, by default, it creates one default VPC for you, and it creates like 4 or 5 subnets for you. That's by default. There's a section where you can create your VPC created by yourself. You can create all the CIDRs and everything that a VPC has, but by default is already created for you. The default CIDR for your default VPC is 172.31.0.0/16. What it means is it allocates 65,536 IP addresses for you. Okay, so each region in your account has a default VPC. Okay, that's something that is a given since the moment you create your AWS account. So if you create a VPC-based resource, Amazon EC2, Amazon RDS, Elastic Load Balancing, etc., those are services that are put inside a VPC, but you don't specify a custom VPC, it would automatically be placed where? In your default VPC. Okay, that happens by default if you don't specify anything. Okay, so your default VPCs include a default subnet. In this case, it could be 4. Mine has 4 by default. I guess yours too. And in a gateway, the default in a gateway, you can create your own one. It has a main route table. You can create a custom route table. The route table connect the default VPC to the internet gateway, default security groups, and the default NACL. All of those components of your VPC are created by default when you create a VPC. So you don't have to worry about those components. They just come by default after you create your account. Okay. Now, they are configurable the same as all the VPCs. Example, adding more subnets. You can add more subnets to your default VPC like any other VPC. Okay. So default is just the same as any custom VPC. The only difference is that the CIDR that comes with this default VPC is already set for you. You don't do it, right? It's 172.31.0.0/. Okay. What is the default subnet? Default subnet is default in default VPCs created within each availability zone for each default VPC. The public subnet with a CIDR block of 20 is a CIDR block of 20, and that allocates 4,096 IP addresses, and you can convert it and any public subnet into a private subnet by removing its route to the internet gateway. So that's what we said. Can you please mute the mic? That's what we said at the beginning, that what makes a subnet public is that it has a route to the internet gateway. And what makes a private subnet is that it doesn't have an internet gateway route. So you can convert the public subnet into private by removing its route to the internet gateway. Okay. So when a new availability zone is added to a region, your default VPC in that region gets a subnet placed in the new availability zone unless you've made modifications to that VPC. You can delete your default VPC. You can delete your default subnets, but I don't recommend it because you might have some issues. Okay. I recommend leaving it there as is. Don't delete it, and create your custom VPC if you want to create it. Okay. And then when you create your resources, what you have to do is choose your custom VPC. Okay, that's it. Okay, default VPCs and subnets recommendation: use default VPCs and their subnets only for experimenting in your AWS account, right? So if you want to work in production, create your own VPCs and your own subnets. So a good solution to start your getting familiar with AWS platform is by using a VPC, the default VPC. So they provide an easy way to test launching instances of your VPC-based resources without having to set up a new VPC. When it says VPC-based resources, are resources that have to be inside a VPC no matter what. That's what it says, right? So you can have other services that don't need a VPC. For example, Lambda. Lambda doesn't need a VPC, right? But in the case of EC2, RDS, all those guys, they need to be there inside a VPC. So for real world applications, you create your own VPC and subnets. You will have greater control because it's your VPC, it's your CIDR, it's your setup, your own setup. So you have more control and more knowledge of your configurations. And it's possible to reestablish default VPC if accidentally deleted. So there's a way to reestablish that VPC, default VPC. Okay, how do you control the traffic to your VPC? So you have something, like I said before, you have something called a route table in every subnet, right? It's the one that allows subnets to communicate. In this case, in this graphic, we see a local route. So that has a destination, the 10.0.0.0, which happens to be the CIDR for that particular VPC. It means that all the traffic in that particular VPC can be connected to this subnet. because it has a local one. If you want to connect to something else, then you have to create another route entry here that has a target. So if it is a public subnet, it will have here another entry that says 10.0.0.0/0. It means all the IP addresses coming from, and it will have here the ID of the internet gateway. Okay, so that will be for the private, for the public subnet. Now, if you have a private subnet, you're gonna have here this local one, the local one, but also you're gonna have another entry that points, the target is gonna be a NAT gateway or a NAT instance that's gonna allow this private subnet to communicate with the internet, like we said before. Okay, so what does a route table do? It determines where the traffic is routed. The main default custom route tables exist there, and all route tables include a local. All of them come with that. They have that by default. They have a local route entry, and the local route entry cannot be deleted. You cannot delete that one because that's the one that allows traffic inside that VPC. So only one route table per subnet. Very important. You can have 2 route tables. Only one route table, but you can have as many entries as you want. Okay, but only one route table. Best practice: use a custom route table for each subnet. You should have your own custom route table for more control, right? You should have that one. That's good practice recommended by AWS. Now the security groups. The security groups are the firewalls of your EC2 instances. Now, they are stateful. So these are terms that you need to understand. Stateful and stateless. Okay, stateful, it keeps track of the state. Stateless, it doesn't keep track of the state. So what does it mean? That in a security group, by default, all the traffic that is allowed in will be allowed out. That's by default, okay? That's something that you have to understand. Why? Because when I enter your infrastructure, your security group keeps the state of my entry. So it means that if I was able to enter, I'm also able to leave your network. So without any problem. That's why it means stateful, right? It's like I enter your house. Then I have to tell you who am I, right? Or who I am. And then when I go out, I don't have to tell you who I am because you already know who I am, right? So that means that you're keeping my state. You're keeping the state of my name, my physical shape. So you recognize me when I go out, that I am the same person that went in. So that's what it means, stateful, right? So a stateful application that acts as a virtual firewalls controlling inbound and outbound traffic for one or more instances. By default, the traffic of the incoming traffic is denied, okay? And you use allow rules that can filter based on network protocol like TCP, UDP, ICMP. So those are protocols that you can research later. But the main point here is that with security groups, by default, traffic is denied, right? At least coming from the internet. When you create an instance, port 22 is open, but that's for SSH. That is different. Okay, you don't need internet for that one. But anything coming from the outside world, from the internet, it's denied. Okay, so what you have to do is create a rule that opens ports for specific IP addresses or a specific resources to access our EC2 instances, right? So we use a CIDR block or security group to create layers of security to define access to assets. Okay, as a firewall for your EC2 instance or your RDS, relational database system. Okay, So if your inbound request is allowed, the outbound response is allowed automatically. That's what stateful means. That's stateful. If you are allowed into my house, you are allowed out of my house. No problem. I'm not going to stop you, right? That's what stateful means. So we have here security groups, okay, to control the traffic in and out of and between resources. So we have here an application tier security group, data tier security group. So we have two EC2 instances right here, right? And we have two EC2 instances right here. So we have a security group that will be allowing traffic in or out or between services. So if this application here wants to connect to this one, we have to allow through the security groups, we have to allow this guy to access this. So we have to use security groups for that. It's like, you know, a security group, like I said before, it's like a firewall in your computer. Remember, this is a server. This is a server, right? And it has a firewall that restricts or allows traffic into it by simply stating any IP address or any resource specifically. Okay, so like EC2 instances have security groups, so do RDSs, databases. They also have security group. Okay, so for this application to access a database, then the security group of this database has to allow traffic from this web server. Okay, guys, I need you to tell me something. It seems like I'm talking to myself. Too much silent. Are you still there?
You're good. You're good. Keep going.
Thank you.
I'm following.
Thank you.
Just pay attention.
Are you guys understanding?
Yes.
Yes.
If you have any questions, let me know. Okay. You know, this takes some getting used to, because it seems that I'm talking to myself because there's a lot of silence, but it doesn't matter, and I cannot see your faces. So so bear with me. Thank you. So we continue. So how security groups are configured? By default, all newly created security groups allow all outbound traffic. Okay, so what you have to do with the security group is just work on the inbound traffic. That's it. By default, all outbound traffic will be allowed if you allow the inbound traffic. That's it, because like we said before, it's stateful, right? It's stateful. So you create a rule. Let's this application be accessed via the browser, and then we're gonna open port 443 for HTTPS, and then by default, whatever comes out, you know, I access it and I come out, I'm allowed because I was simply allowed in, so I'm gonna be allowed out easily. Okay, that's what stateful stands for, or meaning. So to modify the default outbound rule security groups increases complexity. So you don't have to don't touch the outbound rule. Don't touch it. You don't need that, because, you know, if you tweak the inbound, it will go out. It's by default let out in the outbound rules. So you don't have to work with the outbound rules. So most organizations, what they do is they create security groups with inbound rules for each functional tier web app data, because we have a three-tier architecture. We have a web, which is the web app, web servers. We have the application, and then we have the database. Both the application and the database are in the back end, and then the web server is in the front end, right? So you create security groups for the three of them, for each of them, right? To allow traffic. So you can control that. It's controlled by you. So we have here some security group chaining diagram, security groups rules per application. So we have here the web tier, elastic load balancer, security. The elastic load balancer has also a security group. So the bound rule allow TCP port 443. So we are allowing HTTPS access here. The source is gonna be what? 0.0.0/0. It means any. So this is what? The internet gateway, right? The internet gateway has access from anything. It's the internet, right? So in the elastic load balancer, we can have a security group that allows traffic only from the internet gateway. Nothing else can access the elastic load balancer. The source is the internet gateway only. Now, this web tier security group is allowing traffic from where? Just tell me. Tell me, what does it say here?
Elastic load balancer.
Only the elastic load balancer can access this web server. Only this web server. Okay, so you control this. No one using port 80, no one can enter my EC2 instance, only my elastic load balancer. So that's what we are restricting here with the security group. Okay, so we have another elastic load balancer for the application tier, right? This one is for the web tier, application tier. Now, after the traffic comes here, because we can have the traffic to come from the internet to the web application with the web tier, and then from the web tier to your application tier, we have another elastic load balancer as a single point of entry. And then what we're gonna say is that only allow traffic coming from the web tier security group, nothing else, using port 8080. So port 8080 is like port 80, similar. Some people use 8080, okay? And then if you want to access this this app tier right here, I only gonna let you come through the elastic load balancer. And then if I want to access this database, I only allow traffic coming from this application tier. So basically what a security group does is restrict access or allow access from a specific IP address or from a specific resource. That's it. No more than that. Okay? And a security group works at the resource level, right? At the resource level. At the subnet level, we have this guy. Okay? These are the guys, let's call it security group for the subnet. That's the guy that functions as an extra security layer for my application, from my infrastructure that work at the subnet level. Okay? It's a network access control. Okay? Can you please mute the mic? So it's a virtual firewall that controls traffic in or out of your subnet. Security groups is in or out of your application tiers. And NACLs, this is called NACLs too, is a virtual firewall at the subnet level. So NACLs are stateless, okay? Security groups are stateful and NACLs are stateless. Very important. What does stateless mean? It means that when I enter your house and I tell you I am Dunieski and this is my ID and look how I am, and then let me in. When I enter and I decide to go out, you're gonna intercept me at the door, and ask me for my ID again and my name again. So that's what stateless means. So you don't keep the track of me when I enter. That's why when I go out, you don't know who I am. So you have to ask me again. So that's what stateless means. So you allow also incoming traffic by default and use stateless rules to allow or deny traffic. Okay. Stateless rules inspect all inbound and outbound traffic and do not keep track of the connections. Okay. And allow must be explicitly created. Okay. By default, all traffic is denied, is implicitly denied, right? It's denied by default. We have to allow traffic manually. We have to create an explicit allow if you want to allow traffic into your subnet. So how do we direct traffic to the VPC? Internet gateways allow communication from internet into VPC. Okay, so internet gateway is also known as a IWG. Okay, when you see IWG, that's internet gateway. So are horizontally scaled, so you can increment the number of internet gateways. It's one per VPC. Don't forget that. You're gonna have two VPCs, two internet gateways per VPC. Okay, you can have two internet gateways per VPC, but you can have two VPC for one gateway, one internet gateway. Okay. So they provide a target in your subnet route tables for internet routable traffic. So we have here the users. Users are trying to access this VPC through the internet gateway. And then the internet gateway comes here to this instance with a public IP. That's why we can connect to this internet gateway, because we have a route table that has a route entry to the internet gateway, right? And how many hosts can I have in this VPC? How many hosts? You remember? How many IPs? How many IP addresses can I have here?
65,536.
65,536 total IPs I can have in this VPC. Okay. Okay. So to enable access to or from the internet from instances in the VPC subnet, you must attach an internet gateway to your VPC. Okay. You have to ensure that your subnet's route table points to the internet gateway. We know that already. We have to ensure that instances in your subnet have a public IP. If you have no public IP, forget about connected to the internet. You need to have a public IP address or an elastic IP. An elastic IP is a resource that AWS offers if you want to stay with the same IP address when you stop or terminate your instances, and you want to, for example, in auto scaling, if you want to keep the same IP address, then you can use an elastic IP address. Elastic IP address is free. It's free. The first one is free. As long as it is associated to an EC2 instance. If it is not associated, then it's not free. Okay, so if you are not using an IP address, disassociate it and release it. So 2 steps: disassociate first and then release. Okay, for someone else to use it. But IP addresses are not free, and only one is free, connected to an EC2 instance. Ensure that your network ACLs or access control lists or NACLs and security groups allow the relevant traffic to flow to and from your instance. So here you have resources right now, right off the bat. You have resources to troubleshoot a connection to the internet right here. These 4 steps will help you understand why your EC2 instance, your connection is hanging. I mean, it's still loading and loading and loading. Nothing is connected. You can check all these four points here and see why your connection, your internet or your EC2 instances are not being accessed. Okay, so this is very handy when it comes to troubleshooting. Outbound traffic for private instances, network address. Enable instances in your private subnet to initiate outbound traffic to the internet or other AWS services. Prevent private instances from receiving inbound traffic from the internet. 2 primary options. You can use Amazon EC2 instance set up as a NAT in a public subnet, right? And a NAT gateway. Those are the two main ways to connect from a private subnet to the internet. Don't forget NAT instances and NAT gateway. NAT stands for network address translation. Okay, NAT gateway services. So we have here a very terrifying graphic at first, but it's not difficult to understand. So we have here two VPCs, right? Two different VPCs. One has a NAT instance and the other one has a NAT gateway, okay? And they both have a CIDR 10.0.0.0/16 that allows 65,536 IP in total. So each one has a public and a private subnet, right? So we have an instance in each subnet for the VPC number one, the one on your left-hand side. And in the other VPC, we have a load balancer there. I'm sorry, not a load balancer, a NAT gateway, right? Because in the left-hand side, we have an instance. That's an EC2. In the second one, we have a NAT gateway. Now, we have a route table that has a local route entry in each subnet, in this case, in the private subnet. And then we have another entry that points to the NAT instance. You see there, NAT instance in your right and left-hand side, second route entry. It points to that NAT instance, which allows that private subnet to connect to the internet, right? And then in the right-hand side, we have another private subnet that has the same local entry, route entry, but we have another that points to the NAT gateway, okay? Now, maybe you wonder, Professor, which one, I mean, when do I choose one over the other? Simple. If you want to be highly available, I recommend the NAT gateway, okay? Because the NAT gateway, it's a highly available, right? The NAT instance is an instance. That's it. It's an EC2 instance, a special one, but it's an instance anyway. So if that one, it's off, you lost all the internet connection, right? But if you see NAT gateway, it doesn't break. It's simply highly available by default. Okay, so always if you wanna be highly available, or you wanna be a good architect, don't use a NAT instance. Use a NAT gateway. NAT instances will disappear someday, because when you see the benefits and you see the comparisons, all that, NAT gateway outweighs the benefits of the NAT gateway outweigh the NAT instance benefits. So I think that after I explain this, I think that it's easier for you guys to understand this graphic. I believe that before you saw this, well, in this class, probably if you had seen this graphic, you would have gone crazy. What the heck is this? Why so many? What is this? Because probably you didn't know where everything came from and what everything mean. But now you know. Now you know that we have two ways to connect to the internet. For the private instance, using NAT instance or VPC NAT gateway. Okay. A VPC NAT gateway versus an NAT instance. We have a comparison here. So availability, highly available by default, right? So that's pretty good. That's something that we have to go for. Forget about the NAT instance. Use scripts to manage failover. So remember that, I don't know, not remember because we did it in the morning class, but when you create an instance, you can have some script there inside and you can run servers, you can run things, you can have scripts to manage failover. This one, you have to manually put the script there to failover just in case something goes wrong, how you can failover and still run. The bandwidth, it bursts to 10 gigabits per second. Don't forget that speed is gigabits and size is gigabytes. Don't forget that. Speed is gigabits per second. And the bandwidth of the NAT instance is based on bandwidth of the instance type. Okay, the instance type is T2 micro, T3 macro, whatever instance type you select. that's what's gonna influence the bandwidth. Okay. Maintenance is managed by AWS. That's another huge advantage of NAT gateways, that you don't have to worry about any maintenance. AWS will do it for you. Okay. Now the NAT instance is managed by you, so you have to take care of all the headaches and all the ins and outs of that server. Okay, which is a big reason why not to have a NAT instance over a NAT gateway. Security, it uses NACLs. NACLs it's more in the subnet part, okay, and NAT instances use a security group and NACLs both. So in that case, I would give it to NAT instance because they have a double layer of security. Still, that's not the only thing that you have to consider when choosing one over the other. Port forwarding is not supported for NAT gateway, so you don't forward to another port. For NAT instance, you do. You can send traffic to another port with the NAT instance. The scope is availability zone because use an availability zone, and the NAT instance is the same. So the scope, it means the range where it can reach its availability zone. Okay. Good. Subnets and gateways and routes. So we have another horrifying graphic here, but I think that as you see them more and more often, it's gonna be easier for you to understand. But it's not difficult. It's just a little messy. It looks messy. But here we have another VPC, right? That has two availability zones, and the VPC is inside the region, right? And we have another DynamoDB. If you take a look at this here, and the left-hand side is a DynamoDB. A DynamoDB you see is outside the VPC network. What does it mean? It means that DynamoDB is not a VPC-based resource. You don't need a VPC for that one, okay? Whatever is inside this VPC is a VPC-based resource because it needs a VPC, right? But this guy can be accessed from the internet right here, directly from the internet using an internet gateway, right? And then you get it here. Now, this guy here, this is like a router here. That's a route table here, router. It has a destination and the target local, and the other target is NAT gateway. It's right here, right? So we have here a private instance. The IP address is private. Why is it private? Because it doesn't have a connection to the internet. What it has is a connection to the NAT gateway. To the NAT gateway, right? The NAT gateway, the NAT instance is here. So it has a connection to the NAT instance. And the NAT instance is the one that has a connection to the internet gateway here. Okay. So we have a CIDR here that has a 24 CIDR notation here. Okay. You can calculate how many IP addresses are in total here. You have another CIDR here that is in 23. So we have here 4 and we have here 0. Like I said before, IP addresses cannot overlap because we are inside the same VPC. And by the way, this VPC has a CIDR notation 20. Okay. You can calculate how many hosts you can have a CIDR notation 20. All right. So I think it's basically the same. And this guys here, both this private subnet and this private subnet here, these two private instances, they both pointing to the NAT gateway. Okay. Takeaway of this graphic: you have private subnets, and the only way a private subnet can communicate to the internet is through the NAT gateway or NAT instance. Okay. And then the NAT gateway or NAT instance will be connected to the internet gateway through a routing table like this one here. You know, this NAC instance has a route table that points to the IGW is the internet gateway. Okay, so this, as you can see here, is a route table. That's the legend here. You know, this little symbol here is a routing table or route table. You see one here that has this route entries, and then you see another here that has these route entries, and you see another here that has these route entries. Okay, so I hope it's not difficult for you guys to understand it, but that's basically it. I don't think it's difficult to understand. It's a little, you have to pay attention closely, but I think that going over this graphic over and over again, you become very familiar with it, and then it becomes much easier to understand it. Right?
I have a question.
Go ahead.
So right now the DynamoDB, it's outside of the VPC,
Yeah.
and accessible through the public internet, through the internet gateway, right?
Mm-hmm.
Are the other databases the same way? There's
No, the DynamoDB is the only one.
Is the only one. Okay, thank you.
You have to create a VPC endpoint, like we said before. Remember, VPC endpoint.
Uh-huh.
So you don't have to be inside the AWS backbone network. You can go straight from the internet and get it here. Now,
Okay.
this is an entirely managed, a fully managed service. So you don't have to worry about the security of this guy. AWS will manage that for you. All right. So you don't need any security groups or any NACLs, anything. AWS manages everything for you. This is a heavy duty service. Right? Expensive too.
Oh, yeah. But they have other types of database configurations or systems that you could use
Correct.
with AWS. And I was wondering if you can put that inside your virtual private environment.
Which one?
Or
DynamoDB?
Yeah, there are other database
Yes.
that you can create, right? It's not, DynamoDB, it's one of them.
Yeah, DynamoDB is a one single table database, right? It's a fully managed service. We also have you only have two. You have either DynamoDB or RDS. RDS is relational database system. Now inside database, the RDS, it supports 6 different DB engines. So you can have a SQL Server, Postgres, Oracle, MariaDB, Aurora.
Oh.
So you can have all those guys in the platform of RDS, right? So those guys, they need to be inside a VPC because they are a VPC-based resource. DynamoDB has nothing to do with VPC. When you create a DynamoDB table, there's no choice anywhere where you have to select a VPC.
I wonder, because it's a fully managed system, is that the reason why they left it completely outside?
No, it doesn't need a VPC survey component. It doesn't need it. It can be accessed from the internet by itself, alone. It doesn't have to be in a VPC, but for security reasons, you know. It's like I said, it's a heavy duty service. All the security that it has is managed by AWS.
Okay.
In the case of RDS, you have to manage the security because you have to control traffic with the security groups. You have to manage the security groups. So RDS is a managed service, but it's not fully managed. So that's the difference between fully managed and managed.
Okay.
You don't have to do any patching or anything in your RDS, but you have to configure it. Okay. You have to do some configuration there. So it's
versus Dynamo. Are we going to go through this? I don't want to go into more detail if you're going to go through this at a later point.
Yeah, when we get to the databases.
Okay, thank you.
Yeah. So we continue here. How should you monitor your VPC traffic? So there's something that you can do in Amazon VPC is to enable flow logs. You see here, flow logs. So if you have any questions questions in your exam when they tell you how can I get the IP addresses of the computers that are trying to devices that are trying to access my network, you have to enable flow logs. This is not enabled by default. You have to enable. Okay. So you guys don't forget that flow logs. You have to enable them to be able to control the traffic into your VPC. All right. It captures traffic flow details in your VPC. Accept it or reject it. Okay. So the flow logs, you know, is a log, right? It's a log file. It's a log system, logging system. It doesn't restrict or allow traffic. It doesn't. It just capture what traffic was allowed, what traffic was rejected. Okay. Rejecting is knuckles, right? Rejecting is knuckles. Rejecting is security groups. You know, but for logging is flow logs. Okay, you can enable those for VVC, subnets, and elastic network interfaces. That's something that we're going to talk about later. The elastic network interfaces. Logs published to CloudWatch logs. Remember what we said in the first day of class? CloudWatch is one of the most important services in AWS. Don't forget this guy. This guy's going to be with you your entire life as long as you study AWS. That's going to be in every single exam, but at a different level. You know, in your solutions architect, it's going to be in the cloud practitioner on a lower level. At a lower level, it's going to be a little higher in complexity with the social level, but it's going to be much higher in the professional level. Because it integrates with all the services that increases the level of complexity with CloudWatch. But CloudWatch is a tough guy. I would say it's a tough guy that's going to be there forever. Okay. So the use cases, when do we use flow logs? Troubleshoot connectivity issues. For example, I can know why people are not able to connect, so I can check the logs and see that. I can test network access rules. I can just test if a specific IP address can access my network. If a specific address is rejected, I can test that before I just send it to the public. I can monitor traffic, you know, check what came in, what was rejected, and detect and investigate security incidents just in case something happened with like a breach or something. I can know who was who the perpetrator was. How you connect multiple VPCs to each other? I think you have the answer already. Remember, what's the answer?
Peering.
Answer is yes.
VPC peering. Okay.
Mm-hmm.
So here we have something that was. I mean, this is like the anti-pattern. This is a little, you know, it's overwhelming to hear. Before VPC peering, this is what AWS did. I mean, you have one tunnel, VPN tunnel, virtual private network tunnel. So you have a customer gateway, which is on the customer side. So you have one public IP address per customer gateway. It's a lot of work. AWS provides two tunnel destination per region. So this is an alternative to VPC peering, but I think it's a lot of work, you know, because it's a lot of components and involved in this. So in this case, you will have to maintain unique IP addresses on your end and on your route. So you can have a VPN hub and spoke architecture to work around this situation. However, is it really an efficient solution? I don't think it's efficient. What's efficient is this guy. Okay, so you can establish a VPC peering connection to connect 3 VPCs here. Now, like I said before, this VPC here is connected to C, but C is connected to V. Now, B and A are not connected unless you establish a peering here. Okay, So these three VPCs are connected because I have a connection to each other. Otherwise, they're not connected, right? You have to connect VPC to VPC to be able to have, or to be able to achieve VPC peering, okay? And how does it work? The owner sends a request to create VPC, right? Now the owner of the VPC, peer VPC, accepts the connection. And to enable flow of traffic at a route, you have to have a route for the connection, update security groups rules. Security group, they have to be there because inside these VPCs, don't forget that we have resources. Don't forget that we have EC2 instances, we have databases. What we see here is just a little cloud here. It's a cloud because it's a VPC, virtual private cloud. But we have to assume that inside all of these little clouds, we have resources, okay? So we have to, enable traffic flow between all of them by updating the route tables and updating the security groups, okay? So VPC peering connection is one-to-one relationship between two VPCs, one-to-one, one-to-one. Like I said, you need to have a connection between A and B. If you have a connection between A and C is connected to B. I'm just repeating myself for you to understand that it's one-on-one, okay? One-to-one, okay? AWS doesn't support like transitive connections, traffic peering. Like because I'm connected to this, I'm connected to that. No. It's one-to-one, okay? Okay, so that's it for now. How does a VPC peering work? Right? There's a limit on the number of active and pending VPC peering connections, okay? VPC peering that does not support transitive peering relationships, like I said before. You can have more than one VPC peering connection between the same two VPCs at the same time. It's only one VPC peering connection, only one, not two. And I don't know, I have no idea why someone would want to have two.
Excuse me, I have a question.
Go ahead.
On the VPC peering, is the transitive peering relationship kind of like a daisy chain almost? Like you can't go through another VPC to connect to another one?
So what I said before, it's here let's
yeah, like they all have to be one-to-one is what I'm saying, right?
Correct. So
Okay.
A connected to C and C connected to B, it doesn't mean that A and B are connected. Okay.
Okay.
But you have to connect one-to-one.
Okay, cool.
So far, AWS doesn't support that. So maybe in the future, I'm not sure. All right. So some MTU across multiple. Oh my God, this is across VPCs, multiple connections. The maximum transmission unit across a VPC peering connection is 1500 bytes. I'm sorry. Bytes. That's the maximum transmission unit across VPC. So that's how fast it can be between the connections. Okay, bytes per second. The private DNS values can be resolved between instances in peer VPCs. So you cannot use this thing like IP address and all that because it cannot be resolved to a DNS in these connections. Right? Remember when we use an IP address that the machine, when we use a DNS, like a domain, a URL, the machine doesn't understand that. So it's resolved it to an IP address that's not supported in peer VPCs. Okay. So here we have, a route table where targets is PCX1. And here we have PCX1. So we are connecting here from one to the other. All right, so this is basically what we spoke about before. So the traffic using inter-region VPC peering, for example, always stays on the global AWS backbone. Everything is inside the AWS backbone. Everything that happens with VPCs. And the traffic never traverses the public internet. And this is very secure because it reduces any attacks exploits, common exploits, or distributed denial of service or DDoS attacks. So this is very secure, in terms of safeguarding your resources. So
Professor,
yes, go ahead.
I'm gonna have to leave. I have a quiz, but I'll watch the video when you upload it.
Okay.
Okay.
So here we have, we are extending our premises network to AWS.
I have to leave also. I have a class at 3:30.
Okay.
I'll watch the rest of the video. Thank you. Thank you for.
Okay, don't forget to study.
Oh no, I won't.
All right, thank you. So we have here two endpoints here. We're connecting our on-premises network to our AWS, infrastructure here. So what we have to create is a customer gateway. Okay, a customer gateway which is created in the on-premises section, and then we have to have a virtual gateway in your AWS. That's what we need to establish a site-to-site VPN connection. So a virtual private network here. And what we're doing is connecting both. This is especially for hybrid architectures. So simply what we need is a customer gateway, right? Customer gateway here on the on-premises side. And we need a virtual gateway on the AWS side. And then, only then, we can access the AWS, your AWS resources, your resources from the on-premises to the AWS infrastructure. So that's if you ever asked in an exam what's the way to connect to the AWS infrastructure from on-premises, using the internet, very important, using the internet. VPN uses the internet, because for no internet, we have another one that is called Direct Connect. That one doesn't use the internet. It works with private links from AWS. Whenever you need to traverse the internet and connect from the on-premises headquarters for the on-premises section to your virtual, to your AWS infrastructure, you need to have a customer gateway and a virtual gateway. So those are the components to establish a VPN site-to-site VPN connection. Okay. So extending on-premises network to AWS VPN. So we have here three on-premises sections here. Okay. So why is this happening? Because this is for high availability, right? So we have data here, or this is hybrid. It means that not all data is in AWS, right? Part of the data is still here in the headquarters, because it's hybrid. Okay, so we should have they have like three here, to make it more highly available. And then if you have three, then you need three customer gateways, right? It's basically the same as the other one, but instead of having one, you have three, right? And you only need a virtual gateway. Okay, so these three on-premises offices, they can communicate to the infrastructure using these components here. Okay, very securely, because it's a private virtual network. Okay, so very good. So AWS Direct Connect, that's the other one that I mentioned before. This is the one that provides with a private network connection between AWS and your data center. That doesn't traverse the internet. So it's through private links that AWS has. So it's a network service alternative to using the internet to access AWS clouds. If you think about this, what do you think is going to be more expensive, a VPN or Direct Connect?
Direct Connect.
Direct Connect.
Correct. So it's going to be more secure, because it doesn't traverse the internet. So, and it has private, like people dedicated to you. So that's gonna be more more pricey. So what are the benefits of this? A dedicated private fiber to AWS. So what AWS uses fiber optic fiber for this, and it's private. It creates a virtual interface directly to the AWS cloud. It provides access to AWS in the region it is associated with. And it provisions a single connection and use it to access public AWS services in a region in the US. And in AWS GovCloud, more locations being added. Like we mentioned before, some regions that has to do with the government that are already in place, and there's some more that are in the works. So in other words, each one has its own benefits. You know, if you want to go with cost, you would go with the site-to-site VPN. If you're going to go probably more secure and a little faster, then you go with Direct Connect. Okay. So here we have a graphic at a high level. So there are the various ways in which you can connect to the on-premise data center to the on-premise data centers to AWS resources via Direct Connect. In this diagram, you can see the connections between public virtual interfaces or VIFs to public endpoints and private virtual interfaces to private endpoints. So you have here the public endpoints in AWS. So we have here DynamoDB. We have here all the services that they don't need to be in a VPC. And you have other VPC resources here. And then you have account number 1, account number 2 that has a private cloud, a VPC here. It has another private cloud. So we have 2 private clouds here. And then we have 1 private cloud and 1 public endpoint. Okay, so we have the AWS Direct Connect router just in place here for you guys. And then you can connect through these public virtual interfaces, VIFs, or you can connect to the private ones that connect to this virtual private cloud. Because you know the virtual interface is going to be based on whatever you have here. If it is public, you're going to have a public virtual interface. If you have a private PVC, you're going to have a private VFF. The same happens here. We're going to have 2 private ones, and they're all connected to this guy here, okay, that works with VLANs, so virtual local area networks that have here. And then you're going to have this guy, the customer router, in the on-premises side. Okay, so it's a little you know, high level. This is much more complicated, but you need to understand that that's another way to connect to the AWS through a Direct Connect router that doesn't traverse the internet, but it is you know, they're connected through these private links here, private connections here, and they're going to be, you know, depending if it is a public endpoint, it's going to be public, and private is. These are here we have the resources that are that are VPC based, and here we have the ones that are not. So they're in the public, so you go straight to them. You don't have to go through the NACOs and through the security groups or anything. Just go straight to these public endpoints. It's that simple. So, like I said before, you want to go with security. This is the way. More security. They're both secure, but this is more secure. You're going to go with the cost VPN site connection. Okay. So here we have more detail. Here is a basic diagram of how a single router and a single port connection to AWS over Direct Connect will route traffic, along with how the traffic will flow in case there's an issue with the Direct Connect connection, and a VPN connection is used as a backup. So we have a backup there too. So it is important to understand that AWS managed VPN supports up to 1.25 gigabits per second throughput per VPN tunnel. Okay, you don't need to become an expert in this networking. This is more for a networking specialty, but for the security, for the solutions architect, believe me, you don't have to know, 80% of this. It's just for you to have a bigger picture of what resources AWS has in place for establishing a connection between the on-premise and the AWS cloud. Okay, so here we have all of this, and at a high level, a little more details. So we have the public virtual interface here, the private one. If you want to work with instances that are in a VPC, this is Amazon S3. Here we have a VPC endpoint that can be accessed through the internet without going through the VPC NACLs and all that. And then you have the AWS Direct Connect router, the customer router. This is the same as the other one, the same as this one, but a little more in details. Okay. So in the VPN connection, like we said before, we have to go through the internet. And like we said before, we need a customer gateway and a virtual gateway in the AWS side. Okay, so high level direct connect and high level VPN connection. Okay. High resiliency for critical workloads, simple connection, multiple locations. So we have here an AWS Direct Connect connection to separate AWS Direct Connect routers into 2 locations from 2 independent configured customer devices. So this must be used for critical production workloads that require high resiliency. The reason why we have more than one multiple locations is to do what? What are we trying to accomplish here since day number 1 in this class? What are we trying to accomplish? As an architect, always accomplishing what? Every time you see more than one, the same thing, more than one, what are we trying to accomplish? Guys?
Redundancy?
Yes, all the time, okay? So we have an exact replica here. You have like AWS Direct Connect location 1, location 2, and then customer data center 2, center 1, and then we have the CIDRs here. And then we are trying to be more resilient in this case. So we're connecting this to a virtual private gateway from the AWS VPC section. I have a question for you. What is this? What is this? Where do we see this IP address, this CIDR notation? Where?
Private.
I'm sorry?
Private IP address. No?
Are you sure about that? What is this CIDR for? I mean, what service has this CIDR by default?
This is a network which has 65,536 IP addresses.
Right there, you see it?
Mm-hmm.
So the default VPC has a CIDR of 172.31.0.0/16. That's the VPC that is created for you when you create your account for the first time. Okay. So what you see in this graphic is the default VPC, right? So here we have redundant active AWS Direct Connect connection. So for maximum resiliency, separate connections terminating on separate devices in more than one location is the recommended architecture. This topology provides resiliency to device failure, connectivity failure, and complete location failure. So if this location fails, we have this location, okay? So we have a bunch of routers here, okay? And we have here, this is S3. And, sorry, the different services, and we have more than one location. It's recommended, highly recommended, Okay, so this is basically the same as this, but we have some other resources to make it even more resilient.
I have a question.
Go ahead.
Where's the maximum bandwidth support direct connect services?
Well, it can be as fast as 10 gigabits per second.
Okay, thank you. This is fiber optics, yes?
Yes, it's using fiber optics. So it supports speeds over single mode fiber, 1 gigabits per second. That, you know, when it's 1000 base LX, that's it's on 10 gigabytes, 10 G base R. That's 1300 nanometers. So that's even more, you know, of the networking part, but it can support up to 10 gigabits per second. That's super fast.
Okay.
This is a fiber optic. Yeah. Okay, so dual X connection. So with virtual interfaces on each connection to show you of how much diversity and resiliency you choose to deploy depends on your specific resiliency needs. So it comes down to the need of the service of the business. Okay, so you can have a very complex architecture or a very simple one. It depends on your needs and how much money you're willing to spend. Okay. Okay, so best practices, VPC consideration and best practices. This is one of the main takeaways of this lesson. You choose a CIDR block or IP address that ranges wisely. Plan ahead. It's what I said before. Remember, you have to plan ahead because once you create the CIDRs, you cannot change it. Okay. Use the subnets to divide resources based on access. You know, private or public. Segmenting the network. That's a very wise decision. You have to use. You don't have to. You should use multi AC deployments in VPC for high availability. Minimum 2 availability zones. Use security groups to control traffic between resources. Very important to allow traffic into an EC2 instance or a database like RDS. Use the VPC flow logs to track and monitor your VPC traffic to just capture the IP addresses that were allowed in or rejected. So that's very good. That's something that you can allow. You can also allow enable the logs, access logs from the load balancer. Load balancer has also logs that you can enable and use it too. But a VPC, it's broader because it's the big picture. Load balancers are inside the VPC. So if you want to get something that was rejected before it got to Elastic Load Balancer, then you can go to VPC because, you know, a VPC and the access load balancer, we capture only what was allowed in from the VPC. So it's going to be kind of limited. So it's better to use a VPC flow log to capture everything in the big picture. So check the health of your VPN link via API calls or the AWS Management Console. So once you create the VPN site-to-site connection, that's going to be that's all done in the AWS Management Console. You can just check the health of that connection there by checking, you go there and check it. So we have here this architecture. I have a question for you. How can you improve this architecture? How can you improve that? Just think about it. How can you improve that? What's missing there?
Another availability zone.
Yep, the second zone.
Very good. That will be one thing. What else can we do?
Elastic load balancing, aggregate.
Okay, that's pretty good. What else can we do?
The NAT gateway.
Okay, the NAT gateway, that's right. So you got it right. So we have here, you see how this improved a lot. So you have a NAT gateway here. You know, you can either use a Bastion host or a NAT gateway. Okay, but remember, if you want to make it highly available, I would use a NAT gateway more than the Bastion hosts. Okay, Bastion host is like a jump box. Remember the proxy server, similar to a NAT instance that connects these private guys here with the internet. You can use a Bastion host, but I would prefer this guy. That's why it's in green. You know, it's preferable to use a NAT gateway instead of a Bastion host. And also, you have another availability zone, which you got it right. You guys got it right. It's minimum 2. Don't forget that. Okay. Now, review. We discussed how to choose a region. Remember what were the 4 components to choose a region? Remember? You remember?
It has to do, hold on, with governance.
Data sovereignty and governance. What else?
Distance, latency.
Come on.
The proximity to users. The proximity
to users is the only student that I have here, Mr. John. Do I have any other person here? Another voice in the wind? Yeah. Any other any other considerations when choosing a region?
Cost and latency.
Cost and latency. Okay, it's proximity to users. What else can we have? There were 4.
Proximity.
I'm sorry?
Proximity of user to
Good.
data.
Okay, good. So don't forget that. That's the first considerations that you have to have in mind when architecting. Okay. Okay. So we examined how to determine the number of Amazon virtual private clouds, Amazon VPCs to implement. We gained an understanding about VPCs and subnets. We identify ways to control VPC traffic and connect multiple VPCs. We looked at the integration on premises and components. We reviewed the default VPCs and subnets, identified the VPC best practices, and we did an exercise of high availability. Okay, I think that that's it for today. I think that we had a long discussion today. Well, actually, kind of discussion, more of a lecture than discussion. But guys, we learned a lot today. We had a lot of content and a lot of new stuff that contribute to applications being more highly available. Do you have any questions? Do you enjoy at least my talk? Did you learn something new today? Tell me.
A lot.
Yeah?
Yeah.
Okay.
It's very interesting. I mean, to me, it takes me back to my my bachelor days when I was studying for computer information system, like designing systems and taking into consideration clients' needs or expectations, try to figure out, you know, growth and all that stuff. So for me, it really is very interesting.
Okay, I have 18 students that are connected. And it seems that John Dubois is the only one that's paying attention to my talk. Can anyone else tell me something? I love to hear your voice.
Yeah, I replied you many times.
Huh?
I responded many times.
Yeah, I know. Yes, but you know, it's kind of I feel like lonely.
Oh, okay. No, we'll let you speak. Otherwise, you will not be able to speak.
Yeah. I understand. So anything that you want to add, anything that you want to comment on this?
That's a very interesting combination of security and networking solutions.
Okay, okay. I believe that for someone that has some networking knowledge, this is not new at all. I mean, completely new. I think it's the same principles, but applied to the cloud. So,
yeah, it's a little bit different, but
yeah,
something names are different, so you have to absorb those names, new terminology. That's the only thing. The rest, I think, is easy.
okay. So what I want you guys do is to go over this PowerPoint. If there's something that you don't understand, if there's something you understand, you don't need to do it. But I want you to just watch the videos that that will be sent to you. Read the documentation of AWS. Don't worry. Next week, I'm gonna start giving you access to exams for you to start practicing for the exams. And the key for this is that you have to take the exam over and over again until you become familiar with it.
Right.
Okay? We're gonna continue on Friday, gonna continue with different topics. This solutions architect thing has a lot of topics and a lot of content, but you have to take everything one day at a time and don't procrastinate. Don't leave everything for the last minute. Remember, we're aiming at taking the exam before July 1st. Okay?
Right.
Before July 1st. Why? Because on July 1st, the exam is going to change. Okay?
Mm-hmm.
And I don't know anything about that exam. I haven't taken it. And still there's no I mean, no one has an idea what's going to be in that exam because no one has taken it. It's going to be effective on July 1st. But I'm taking this exam right now, the one that is currently, the current one, and the people that created exams that you guys are going to use already took that exam. They have feedback from the students, and I recommend being on point, study every day on top of the content, because we will aim for, I'm taking the exam before July 1st. Okay. So
what is this certification called?
Solutions Architect Associate.
Associate level, okay.
Okay. So you have 2 months. 2 months is more than enough to get certified. Okay.
Mm-hmm.
But you have to put in the time. I'm sorry if I repeat this to you every day that we meet. You have to put in the time. Take me. I repeat it all the time. I took this one exam like 14, 15 times until I first felt confident. And even when I felt confident, I took it like 2 or 3 more times. So you have to put it that, and I believe that you will get certified if you put in the time and the effort. Okay? So when we start with exams, both collectively in class, we're gonna take exams in class, and you start taking exam at home with the platform that I'm going to provide for you guys, you will be more than confident to take the exam. Okay? But you need to study. You need to study. And don't feel overwhelmed if there's something you don't understand now. If you don't understand the basics of AWS, I posted the morning link, the morning session link, so you can attend my morning session, no problem, without any commitment, for you to understand the basics of AWS. And then it's going to be a solid complement to this class.
Right.
Okay?
Mm-hmm.
So do you have any other questions? Do you have any other questions?
Yes, Professor. By any chance, will the morning class be on YouTube?
It is on YouTube already.
I looked, it doesn't have the full video. It's only a minute long.
Really?
Yeah.
How is it possible?
I'll keep looking, you know.
Oh.
Check it out, you know, see what.
Okay.
It's a live, so it's gonna say 1 minute, but it's like the hour of the class, or like the length of the class.
Oh, okay.
Okay. Okay.
I have a question.
All right. Thank you.
Go ahead.
Yeah, a question. So I was in the class in this morning. Can I take the exam to certification or
Well,
not?
for that class, you need to be enrolled in that class. So it's what I said on Monday. You can participate in the morning class, but you would not take advantage of the benefits of being enrolled in the class. It's like now, one of my students in the morning, they want to be in this class, they would not be able to get certified as a solutions architect because they're not enrolled in this class. You understand?
Okay.
You need to be enrolled in the class to be able to get all the vouchers and everything.
Can you pay for the test on your own?
Yes, you can.
Okay.
Yes, you can. And by the way,
as an architect, sorry.
Okay. Okay. In your case, guys, you will have to go with the voucher that Miami-Dade College provides. But in the case of the morning class, they can take that class with the voucher that Miami-Dade College is going to provide. But once you take an exam with AWS automatically gives you a 50% discount for your next exam. So they can take the solutions architect discounted by 50%.
Should we take the practitioner test?
I don't know if you pass this exam, you can use that 15% for an exam that is before. You know what I mean?
But would anyone require a practitioner exam pass grade if you already had the architect?
No.
Okay.
No. And before, you needed an associate level certification to take a professional one. Not anymore. You can take a professional without an associate.
Oh, awesome.
Which I don't recommend at all. That's absolutely crazy because the professional assumes that you have an advanced knowledge of AWS. They don't go into details. They just go straight to the DevOps section or solutions architect professional components. They don't care if you have knowledge of AWS. An associate that is a completely different level. That has nothing to do with the other ones, but it's recommended to have an associate level certification because the professional, the DevOps professional is the professional exam of developer and sysops. And the solutions architect professional is the professional exam of the solutions architect associate. So they highly recommend taking the one below. Okay. And the good thing is when you take the cloud practitioner and then you take any associate level certification, your cloud practitioner expiration date will move forward to the day that you get certified in the solutions architect. So it's recertified. You know what I mean? So
yes.
It's just say you have the cloud practitioner, you took it in November 2020, right? And in November 2020 is supposed to expire on November 2023, right? It's 3 years long. If you take your solutions architect on November 2021, your cloud practitioner, which was given to you on November 2020, then it will expire on November 2024 because you took the associate level 1 year after. So your cloud practitioner will be recertified based on the date that you took the associate level. So basically, the cloud practitioner and the solutions architect will have the same expiration date. Do you get it, guys?
Yep.
And if you take a professional, that's gonna recertify all the associates below that professional. So when I got certified with as a DevOps engineer, my CSOPs and my developer exams were certified, recertified. Now, if I take the solutions architect professional, my solutions architect associate will be recertified too, to adjust to the new date. So that's a good thing. And you get 50% discount for the next test, which is pretty good because, you know, the solutions architect is $150 and the professional exams are $300. So 50%, 150. So you save a lot of money. All right, guys, I think it's been a long day. I enjoy teaching you guys, and I believe you enjoy listening to me and learning. And keep up with the studying, and don't procrastinate, because that's not recommended at all. Okay? So if you don't have any further questions, I will dismiss the class. And I will see you on Fridays.